A caldera in the Sunda Strait between Java and Sumatra grew more turbulent in the summer of 1883, spewing up enormous ash and steam plumes. The next day, August 26th, an undersea volcano released over 25 kilometers cubed, or 6 cubic miles, of debris, hurling pumice ash and boiling lava flows across adjacent towns. Many thousands of people perished as a result of the eruption. Krakatoa's undersea eruption was among the deadliest in recorded history. On January 15, 2022, about 160 years after the first underwater giant emerged from its slumber, another one did so off the coast of Tonga. But the volcanic eruption and subsequent tsunami caused by Hunga Tonga and Hunga Ha'apai were exceptional. Volcanologists captured the undersea mountain's explosive discharge on film, and what they saw shocked them. Satellites photographed hundreds of lightning discharges erupting from the volcano's ash clouds. Still, the South Pacific nation was effectively cut off from the remainder of the globe after the eruption broke an underwater transmission cable, and remote sensors captured the tremendous shockwaves that reverberated worldwide for days. The ash plume reached unprecedented heights and persisted in the planet's outer atmosphere. Nearly 100,000 Tongans have been displaced by the Hunga Tonga eruption, which continues to be a humanitarian crisis and a cautionary story for the rest of the world. However, researchers were forced to reevaluate the risks posed by the ocean's many dormant volcanoes. And in order to safeguard both land and sea, the search has begun for these submerged seamounts. Have you ever seen a volcano eruption in person or on TV? It's truly a sight to behold. Volcanoes are commonplace near the edges of the Earth's tectonic plates. Superheated molten rock, known as magma, can rise through the Earth's crust and erupt to the surface, often in spectacular fashion, thanks to these barriers. About 3/4 of the world's volcanic activity occurs below the surface, since numerous plate borders are at or near sea level. Undersea volcanic activity is an ongoing process, altering the ocean's features. However, most submarine volcanoes do not exhibit the dramatic eruption occurrences of similar land counterparts. An important part of the underwater volcano is the pillow lava. A pillow lava is a basaltic rock formed when magma cools rapidly upon contact with the cold ocean water at seafloor level. And a large portion of the oceanic crust comprises pillow lava and the slower cooling magma beneath it. Another feature of the underwater volcano is the seafloor spreading. Seafloor spreading occurs when volcanic eruptions create new ocean floors along divergent plate boundaries, like the Mid-Atlantic Ridge. The plates, along with the ocean bottom and continents above them, are being pushed apart at a slow but steady rate of 1 to 15 centimeters per year by this process. Volcanic activity occurs in the Pacific Ring of Fire because of the convergence of tectonic plates, which results in subduction zones. Did you know that seamounts, mountains that rise from the ocean floor, or islands that emerge from the water result from sustained volcanic activity? The Hawaiian Islands are just one of many Pacific island chains generated as a single volcanic hotspot eruption over millions of years as the Pacific Plate travels above it. Volcanoes warrant close observation due to their risks, ranging from sudden explosions and landslides to long-term changes in climate. The ruins of Pompeii, Italy are a stark warning against settling on or near any of the world's many volcanoes, active or dormant. The residents of Pompeii, Italy were buried in volcanic ash from Mount Vesuvius over 1,700 years ago. For a more modern example, in 1980, Mount St. Helens in Washington state erupted, ripping more than 1,300 feet off the summit of the mountain and incurring an estimated $1.1 billion in economic damages due to deaths, injuries, ruined bridges, and loss of crops. The Long Valley caldera, located in the Mammoth Lakes area of California, began leaking carbon dioxide and helium via fractures in the earth in the mid-1990s, demonstrating that even seemingly quiet or dormant volcanoes may prove unexpectedly hazardous. The vapors damaged numerous trees in the neighborhood, and it's possible that some people got sick and even died as a result. When an underwater volcano erupts, what happens? An undersea volcano's proximity to the water's surface determines the extent of damage caused by an eruption. The weight of the water above the volcano functions as a pressure cap. If the eruption takes place at significant depths, according to David Pyle, a volcanologist and earth science professor at the University of Oxford. Molten rock that reaches the ocean at a depth of 2 kilometers or 1.24 miles will rapidly cool when it comes into touch with the cold seawater, and extreme heat will be applied to the water, but no steam will be produced. On the other hand, if the water is shallow enough, the magma will begin to heat it, turning it into steam, and the result is a dramatic shift in volume. As stated by Pyle, a small amount of water may produce a massive amount of steam, which is why steam explosions are so destructive. When an underwater volcano erupts in shallow water, you have to worry about the possibility of tsunamis and the massive amount of ash that is released into the air. Besides contributing to air pollution, the ash fall and released gases can disrupt the delivery of essential services like electricity and water, as Pyle explained. Submarine eruptions are infrequent to document since they're typically buried by kilometers of ocean water. However, scientists hope that past disasters can help them predict future ones. For instance, in 2018, a massive new seamount was formed due to an undersea eruption near France's Mayotte Island, indicating a significant level of seismicity in the area. Scientists now keep a close eye on Mayotte, updating their data on Rivosima, a centralized platform that tracks seismicity, volcanic dangers like a magma flow, and water temperature and acidity. Significant but prohibitively pricey is the effort of Rivosima in the case of continuous eruptions, and installing a cable near a volcano for local data collecting can be quite expensive. Even funding and establishing infrastructure might take a very long time. However, the study is essential, not simply to determine the threats posed by active volcanoes, but also to gain insight into the ecological effects of these phenomena. But why go through so much trouble, you'd ask? Considering volcanic activity is often accompanied by recurring themes of devastation, as human perturbations like mining, ocean trawling, fishing, and other extractive operations, studying how they occur can teach us about how ecology recovers. Submarine volcanoes can have widespread effects, mainly if they cause the seafloor or nearby areas to be covered in sediment or otherwise agitated. Volcanoes pique the public's attention because of the danger they pose. According to Javier Escartin, a bathymetric researcher at the École Normale Supérieure in Paris and the Laboratoire de Géologie, volcanoes located deep below are not typically considered dangerous. But those that are either emerging from the water's surface or are located close to it are. Of the roughly 1,500 volcanoes on Earth, only around 500 have erupted during recorded history. Nonetheless, there is a continuous belt of volcanoes on the ocean floor, numbering in the hundreds if not thousands. Most of these are probably situated in the area known as the Ring of Fire, an area which enriches the Pacific Ocean and inhabited the volcanic islands. It poses the most significant risk to us. Without extensive bathymetric data, how do volcanologists look for these undiscovered undersea volcanoes? In this case, hydroacoustic monitoring could be the solution. Underwater volcanic eruptions generate acoustic energy, which can be heard as everything from sharp cracks and thundering booms to quiet rumbles. And as lava is hot as 1,200 degrees Celsius or 2,192 degrees Fahrenheit, reacts with nearly freezing seawater and vaporizes, releasing its thermal energy as sound, at the seafloor level boundary, a sort of Goldilocks zone for those listening for underwater vibrations, seismic energy is converted to underwater acoustic energy. Pressure, temperature, and salinity all work together to impede the flow of sound through the water to depths of about 1,000 meters, or 3,300 feet, making transmission possible. However, the sound detection and ranging, SOFAR channel, is located here. Whales use this same acoustic channel to communicate with one another underwater. Sound waves generated by seismic energy conversion along the SOFAR channel can be picked up by hydrophones or underwater microphones, and this acoustic information may be used as an early warning system for volcanic eruptions, as it provides hints about the emplacement of lava flows. The United States employs a team of geologists, volcanologists, and other specialists trained in volcano hazard assessment, monitoring, and emergency response as part of its Volcano Disaster Assistance Program. For more information on volcanoes, the U.S. Geological Survey has compiled a useful resource. However, guidelines for tsunamis caused by undersea volcanoes have yet to be drafted. As more findings are underway, we hope that a day will come when humans will fully understand how underwater volcanoes can be predicted better.